Okay, you're right. Welcome to your video tutorial on area of a sector. Now, first off, we need to know what in the earth is a sector. A bit of revision before we begin, and a slight spoiler alert. A sector is part of a circle, okay? So we need to make sure that we are absolutely 100% sure of how to work out the area of a circle. The area of a circle is worked out with this formula here. Pi times the radius squared. Sometimes it's showed like this, pi r squared. We know from algebra that the operation that's going on between them is multiplication. I've just written it out really nicely for you. Okay, so today we are going to be manipulating this formula that we already know to work out the area of sectors. A sector is formed by dividing a circle. It is not a whole circle. Okay. A sector's area is determined by calculating what fraction of the area of a circle do we have. You might notice our friend pi times the radius squared over here, this guy. All we're doing is we're saying we have this fraction of pi r squared. Okay, so it's still the same formula, pi r squared, but because we only have a fraction of the circle, remember a whole circle is equal to 360 degrees. That's why we're saying we have a fraction of pi r squared. Okay, let's have a look at our first example. Find the area of this sector correct to 2 decimal places. Now I know my area is my fraction of the circle times my formula pi. Now, if you want to write in that times in there, you can if that helps you remember. That's fine. The first thing we need to do is we need to work out, well, what's this? What fraction do I have? And what's my radius? Okay, so my area is, what fraction do I have? Well, I have 120 over 360. And I'm timesing that by pi times my radius is 2 squared. Okay, so my area is going to come to, now I'm just going to simplify here, 120 over 360 will also be known as a third, times pi times 2 squared is 4. So this line of working here is not absolutely essential. I just want to show you the simplified version. And if we plug that in on our calculator, we get 4.1, and now we're going to round it to 2 decimal places, so 4.19 centimeters squared. That's rounded to 2 decimal places. So what that's saying is if I have a part of a circle, if I have a third of the circle and its radius is 2 centimeters, this little bit in here is going to be 4.19 centimeters squared. Okay, what makes this question different? Well, you might notice that this 70 degrees is on the outside. Okay, so to work out, remember, I'm not concerned with what's on the outside. I'm concerned with what part of a sector I have. I actually have all of that in there. So I have to quickly work out 360 minus 70, okay, becomes 290 degrees. Okay, so I have to go, okay, my area equals something over 360 times pi, the radius squared. Okay, so my area is 290 over 360 times pi times, now I'm writing that times in there for you, times, this is 5 meters. Okay, this radius is labeled as 5 meters, so times 5 squared. And if I put that in on my calculator and I round to 2 decimal places, I get 63.27 meters squared. Okay, so 63.27 meters squared. Now, why is that bigger? Well, let's have a look. Okay, my radius was obviously bigger, but also I had a bigger portion of my circle. I nearly had, well, I had over 3/4 of it. I nearly was creeping towards a whole circle, whereas the other one, I only had a third of the circle. So it's really important. Sometimes you'll get given what portion of the circle you have nicely, and then other times you'll get given it like this, with the 70 degrees on the outside, and you having to work out the difference.